So in this question, we're given a cumulative distribution function, which is given as this equation here. F of x is 1 minus 1 over x squared, where x is always greater than 1. And we want to find the answer to these 4 questions. So the first 2 are probability questions. Then we're going to find the PDF, and then we're going to find the interquartile range, all from this function here. So first of all, let's have a look at the cumulative distribution function. So let's just graph it. So if you've got our y-axis here, and this is our x-axis. Now, x is always greater than 1. So we're interested in this point here onwards. Now, 1 minus 1 over x squared, when x is 1, this will be 0. And as x gets larger and larger, it will approach 1. So if on our cumulative distribution function here, we've got our value 1, we draw a dotted line across. Cumulative distribution function will follow that kind of a pattern. Now, the cumulative distribution function, as it's the total of all the probabilities, it's always going to be monotonically increasing. So it will never be going downwards. It can go along in a straight line, but will never go downwards. Okay, so probability x is greater than 2. So let's have a look at that on the graph. So if x is 2 here, following up the line here and going along, we'll see here, this value here, that's the value we're interested in. Now x is greater than 2, so we're only interested in the values, these ones here. Now it looks like there is not so many values greater than 2 than there is less 2. There seems to be more value here. So let's see what value we get. Let's plug that into our function and see what the answer is. So our function here, cumulative distribution function, f of x equals 1 minus 1 over x squared. So the probability x is greater than 2. What we need is 1 minus our cumulative distribution function, which is 1 minus 1 over x squared. And now, for the probability x is greater than 2, we just need to plug in 2 for our x's. So 1 minus f of 2, 1 minus 1 over 2 squared. Okay, so now what we've got is 1 minus 1 minus 1 quarter. So 1 minus 1 quarter, all in brackets. So this will be 3 quarters. So now we've got 1 minus 3 quarters. So then that will equal a quarter, which is 0.25. So that's our probability of x being greater than 2. It's 0.25. So therefore this value here will be 0.75. Okay, now the probability x is less than or equal to 3. Let's have a look at that. Take this off the board and we'll do the calculations. Okay, so now for the probability x is less than or equal to 3, let's go to our graph, put in the value 3, follow it all up, and we get to this value here. So we want all of these values here, all along this. Now, as this is typically the integral of our PDF, what we're looking for basically is the area under this curve of our PDF. So as that's our integral, we just need to plug in our value 3. So therefore we've got probability x is less than or equal to 3 equals f of 3. That's all we need. So then we've got 1 minus 1 over 3 squared, which is 1 minus 1 over 9, which equals 8 over 9. So in decimal form, that's going to be 0.88 recurring. So I'm going to write that as just as a fraction. So we get the exact value. So that will give me 8/9. So therefore this value here, coming along there, that will be 8 over 9. Okay, so let's take this off the board and we'll do the PDF. Okay, so now we're going to find the PDF. Well, as this is an integral, and it's the integral using the PDF, if we take the derivative by the fundamental theorem of calculus, that will be our PDF. So our f of x equals the derivative of our f capital of x with regards to x. So therefore, plug in our cumulative distribution function. We want the derivative of 1 minus 1 over x squared with regards to x. So take the derivative of this. Derivative of 1 is 0. And then derivative of 1 over x squared. So the derivative with regards to x of 1 over x squared, that's the same as the derivative with regards to x of x to the minus 2. Well, when taking the derivative, bring the minus 2 to the front and then drop the power by 1. So minus 2 minus 1 is minus 3. So then that equals minus 2 over x cubed. So now what we do now is subtract 2 over x cubed. So then that equals 2 over x cubed. So that will be our PDF. That's our probability density function. So that takes care of that. So that's 2 over x cubed. Okay, so now we're going to find the interquartile range. Okay, so now on to finding the interquartile range. Now the interquartile range has different values of A. So for example, the median is at A equals 0.5 because that's the middle value. And our lower quartile, that's at A equals 0.25. And the upper quartile, that's at A equals 0.75. I just put these as arrows. Okay, so what we need to do now is use our interquartile function using our cumulative distribution function. So what we do is we set it up like this. So we set it up as A equals, so that's the value where we want to find our medians or our upper or lower quartiles. And we set that with our cumulative distribution function in terms of our QA. So our quartile function, 1 over QA squared. So now what we do is solve for our quartile. That's what we want to do. So let's get this on its own. So if we bring this to this side and then subtract A from both sides, we'll get this on this side on its own. So 1 over QA squared equals 1 minus RA. Okay, now what we want to try and do is to get this QA squared on its own. So now what we do is divide both sides by 1 minus A, and our QA squared, we multiply both sides by that. So then these two can flip-flop. So now we've got 1 over 1 minus A equals QA squared. So now just to get this on its own, all that's left is to do is take the square root. So take the square root of both sides, and now we get our quartile function is the square root of 1 over the square root of 1 minus A. So we could do square root of 1, which is just 1, and then the square root of 1 minus A, which is what we're going to need to leave in our denominator. So that's our quartile function. So now what's left to do is to plug in when A is 0.25 and A is 0.75 and subtract the difference. So let A equal 0.75. Let's do that first. So if I just put a line down here, so for Q of 0.75, I just plug in 0.75 for this. So that equals 1 over the square root of 1 minus, and A is 0.75. So that's basically we have to plug in there. So now we just calculate what that is, what that value is. So now we've got 1 over square root of 0.25, which is, let's put that in a fraction because that's easier to deal with. So 1 minus 0.75 is a quarter. Well, then that's going to leave me with 1 over square root of 4, which is 2. So then the 2 could go on the top. So then this just equals 2. So our upper quartile is 2. So this one here, just write that down in there. That's the value 2. So now let's calculate our lower quartile. So Q of 0.25. So what I'll do now is plug in 0.25 for this fraction here. So that equals 1 over square root 1 minus 0.25. So that's 1 minus a quarter, which will leave me with 3/4. 1 over square root of 3/4. So that's the square root of 3 over the square root of 4, which is 2. Which then just gives me 2 over the square root of 3. So that's what my lower quartile value will be. 2 over square root of 3. So all I need to do now is subtract the 2. So now I've got my interquartile range is my upper quartile, which is 2, and then subtract 2 over square root of 3. Okay, that could be fine as our answer, but we can do better than that. Multiply top and bottom of this by square root of 3. We've got 2 root 3 over root 3 minus 2 over root 3. So 2 root 3 minus 2. So now I've got 2 multiplied by root 3 minus 1 all over square root of 3. So that would be our interquartile range. That's our value, which comes out to 0.845. That's approximate value. Now what that means is our interquartile range gives a value of x, which is approximately 0.845. So the upper quartile, which is a 0.75, which is basically equivalent to our probability of x being greater than 2, we already calculated that that was here. So that was our upper quartile value. Our lower quartile value was 2 divided by square root of 3, which would be somewhere around here. So that's 0.25. So that one goes somewhere here. So this value here, and from here to here, this is our interquartile range on the graph of our cumulative distribution function. Okay, so let's write this down on here as our final answer. So 2 root 3 minus 1. Put that in brackets and then divide that by square root of 3. And that's our interquartile range. Okay.